Hello everyone, and welcome back to Adrian's Digital Basement. This is part 3 of the Apple II Plus repair series. Yeah, I guess we'll call it that. If you haven't seen the first 2 parts yet, I advise you go watch those first, because this is a continuation from those parts. In this video, there's going to be repairs actually happening. So let's get right to it. Where we left off in part 2, I had plugged in the Apple II Plus motherboard after it dried out after an extreme cleaning, and there was actually no picture whatsoever coming out of the video output. Had I actually made this board worse? So the voltages seem okay, if not slightly high. I think now I need to bust out the oscilloscope. All right, so we have 6502 pinout on my phone here. First thing I'm going to do on the processor is check that it has a clock and that the reset signal looks good. So this should stay low for a second and then go high. There it is. And then pin 37, this should be the clock input, around 1 megahertz. We're getting 1.02 something or other megahertz. That looks fine. You can ignore all this noise on here. This really has a lot to do with my measuring. I'm not doing a good job with the measurement there. So reset and clock look absolutely fine. Let's check one of the address lines. This is address line 12. We should see activity. Nope. Not doing anything. Address line 13. There's definitely activity for a second and then it stops. Here we are on data line 0. It seems like I saw a little bit of activity there. I'm going to single shot capture. Let's take a look at what we see. We got like the smallest of blips and that's it. But that shows that that line is probably working. Okay, this is data line what is this? Data line 1. Clearly that's got activity. 2, tons of activity. Well, not tons, just it's got it. 3, 4, 5, 6, 7, and this is address line 15. Okay, now this one, notice how it's going up and down? When I push on the pin, it goes up. So I think the CPU may not be all the way in the socket. So I'm gonna pull this out. So I haven't done any reseating or anything. Oh, you know what? It kind of came right out of the socket on the side facing the slots. Oh, and it's got a bent pin. The pin is not completely bent, like it wasn't bent out. It's probably was okay, but actually no, 2 of them are quite bent. But unfortunately, with something this old, I'm going to really suspect that we might be having an issue with sockets. So I'm going to apply a little Deoxit onto the socket as I do. Yes, I'm still using my squeeze bottle because my main Deoxit can broke and I'm still working my way through these. I have a new can, which I can open up, but I am not quite ready. So let's put this back in again, push it all the way into this socket. Okay, now it's in all the way. Now, the fact is we're not getting any video signal, so I'm not totally expecting everything to work. Yeah, it's still like a weird, we're still getting a strange voltage there. But let's just check these lines. At least they all look right. I'm not getting that kind of up and down floaty. Oh, no, this one is still doing that. What is happening? Okay, I think I'm going to take out these ROM chips. I'm just going to label them so I can tell their orientation. Oh, you know what? Apple actually labeled all these chips. F, yep, they are labeled, so I didn't need to do that. Let's pop these out and just take a look. Clearly someone's been in and about this board a lot. That one's good. And we will take a look if anything looks different on the CPU with these ROMs out. That one has very tarnished pins, but otherwise are okay. Okay, power this up without a ROM. Okay, address lines look exactly the same. We're seeing exactly the same behavior too. A little burst of activity on the address bus, and then nothing. Now, of course, there's no ROMs. The computer will be unable to boot. It's going to try to go to the reset vector, and then it's just going to fail, right? That's a given. So the CPU is out, and I wanted to see what the address bus looks like without the CPU inside. And it's, you know, it's not anywhere. It's just sort of floating in the middle, and that's kind of what I expected, actually. Ooh, that's a warm chip. And then look at the data bus. This is exactly how it looked when the CPU was not in here and the ROMs are out and the CPU is out. So this activity is being driven by something else. All right, so the very first thing we need to do here is figure out why I'm not getting video output. And I know the video output all happens in this corner of the board here. We did have video output before, and I don't think you need anything working on the CPU or whatever to get video output. I think that part of the Apple II just runs directly out of memory no matter what, as long as you have a clock, and we have a clock signal, so we know that's good. So I'm gonna hit the power, and I'm gonna touch the lead that's the center pin on this composite, and I'm getting nothing. And there's no output at all. There's just a little bit of activity, but it's barely anything. Now there's a couple transistors here, and let's see, we'll go on that lead of the transistor, so that's probably the collector, and this is probably the base. Aha, look at this. That right there, that looks like NTSC video. Yep, I would say that's NTSC right there. Let's take a look at the emitter, and we still have a signal. There it is, looks good. That appears to make its way over to this potentiometer here. Yep, there's the input to the potentiometer, and let's see on the output side, it's gonna be hard to get. I think I'll have to tilt the board up. And we have this lead here, we got nothing. And that lead, we do have something that makes its way over to this pin. Okay, that's this, there's a multi-pin connector here. And that's got negative voltage. There it is, there's a video signal right there. Why is it not getting from there to this connector that I had the monitor plugged into? That's unusual. Yeah, I'd say that's a video signal right there. I think if I adjust this potentiometer, I think it should change the amplitude. Not really seeing any change. Okay, and now we have a video signal. So I took a look at the circuit diagram for this part, and this variable resistor here only affects the composite video output, not this header here. And guess what? It was just turned all the way down. I think when I was cleaning the board, I must have bumped it, and I didn't check the obvious and just turn it up. If I plug in the RetroTink now, we will have a video signal. God. There we go, there they are. There are those question marks. And let me turn it down. It should be about 1 volt peak to peak. And it's 1, 2, yep, there we go. That's about 1 volt peak to peak now. Okay, cool, one boneheaded mistake over. Let's pop the CPU out. I just want to confirm what I was thinking, that the video generation absolutely works fine without the CPU installed. We should still have those question marks probably, and we do indeed. So definitely it feels like nothing is executing on this computer. Like this is just the basic state of the RAM when you first turn on the computer, and it feels like the CPU is needed to do anything, right? It's gonna clear the memory, it's gonna put the Apple II banner at the top. The fact that taking this out doesn't change the question marks. In fact, we might just see slight differences if I power cycle a couple times, because of course the RAM might get a couple. That is the RetroTink. You can ignore that problem. That is not an Apple II problem. Come on, RetroTink. What are you doing to power cycle the RetroTink when it does this? This newer one has updatable firmware, but it kind of acts a little funny sometimes. There we go. Okay, so anyways, we saw on that first test with the TV set on part 1, there were occasionally I'd have like slashes and a few other things. And if I pop out one of the low bank RAM chips here, which looks okay, good, nothing bad, we might see something different, because I think it's this low bank. Yep, we're getting some garbage there, and that's because this chip is out. So the video decoding circuitry is reading memory to get the characters out of this RAM, and now we're getting some strange characters because of course that chip is missing. So the fact that we're seeing all question marks, is that a good thing or is that a bad thing? I'm not sure, but I'll pop this back in and I will just pop out another random chip, and we should see similar flashing question marks in a different place. Oh, we're not seeing any difference with this chip taken out. That is intriguing. Let's just try one more chip out. Okay, I popped another chip out. And also no change. Interesting. Well, I say interesting, but that actually doesn't mean much because I really don't know what I'm doing on an Apple II, and I actually need to go read up and do a little bit of studying to see how the video decoding circuitry works. But for now, actually, I'm going to assume that the video decoding circuitry is working okay, and I'm going to focus on the code execution and why the CPU doesn't seem to be running anything out of the ROMs when you turn the computer on. In fact, the CPU is out and I'm looking at the data bus and we're seeing activity. And I'm assuming this is normal because the RAM is being scanned by the video generation circuitry, which probably has the side effect of refreshing the memory as well. And if I go through the data bus lines, probably, oh, look at this one. That's interesting how that looks so different. Okay, I'm just going to quickly look through all the address and data lines here. So address is floating because the CPU is not in, so that makes sense. This is data line 7. Okay, it looks like that other one we saw. So it's pulsing and then there's a little bit of a drop, but that's probably okay. 6, 5, 4, 3, 2. Why does 2 look like this? 2 looks weirdly different. If I pause this, we're just getting a kind of a continual signal on 2. That's very suspect in my opinion. 1 looks normal like the rest, and the 0. So here's something fascinating. Data 0 is low all the time, although I can see what looks like maybe it trying to pulsate. Remember we saw those pulses. 1, 2 is always active. So 0 is stuck low and 2 is always active. Let me write this down on my notes here. So this is the signal on data line 2 and it's running at 1.024 megahertz, the exact clock of the computer. Why is the clock sitting on this data line? That does not quite make sense to me. I can't imagine this is correct. So I'm checking the wonderful book, the Apple II circuit description, and I'm looking for where that clock signal is getting onto the second data bit that's on the CPU, and also why the data bit 0 is grounded. On this page, I'm looking at the RAM, and there are two 74LS174s, and the data bus lines 0 through 7 come out the right side. So these two chips, which are B5 and B8, when I take a look at them, I see that same kind of signaling that we're seeing on the CPU, right? It's moving around a little bit, but yeah, that's basically the same thing we're seeing, right? It is on all 8 data bus lines coming out of these chips. So that problem with that clock signal and the ground is not happening here in the memory circuit. In addition, up here next to CPU is a bus transceiver. It's a part number 8304. And I'm assuming this is very similar to a 74LS245, which seems to be in use on everything else. But if I go through these pins here, there's data bit 2 with that crazy clock signal, and there's 3, which looks fine. And it's not coming from this chip itself either, because I see the same bad signal on both sides of it. Since we are seeing a problem on the data bit 2, I'm going to remove all of the RAM chips that are on data bit 2, because it's possible that I know we're seeing what looks like a clock signal, 1.024 megahertz, but that could be coming from one of the address lines. The address generator that generates the refreshing for the RAM probably is all tied into the clock signal. So it's possible if one of these chips is bad, it is leaking directly onto data bit 0. So let's just pop all 3 of those out in a row. So that would be C5, D5, and E5. And we'll turn this computer on. And sure enough, we're still getting that 1 megahertz clock signal on data bit 2. So it's not the RAM chips and it's not the 174s that go off to the video circuitry. I'm just continuing through the schematics here, looking for things on the data bus that are on D2. So this is the I/O decoding, looks like for the keyboard connector, and it definitely is on data bit 2 and 0, the 2 that I'm seeing an issue on. So chip B6, which is 74LS257, let me remove that IC and see if that changes anything. Okay, B6 is out. Let's look for what we're seeing here. Okay, so things are a little different now. Data bit 2 is just low entirely. Data bit 1 is high. 0 is still low. And 4 is high. That's 5, 6, 7, and 8, or sorry, 4, 5, 6, and 7 is actually how I should have said it. These look normal. So taking that chip out seems to have taken away that normal pattern that I'm seeing. Now it does make sense that I'm no longer seeing that pattern, because this chip, what it does, besides connecting the keyboard, it also interfaces the RAM data bus, the latched outputs, to the regular data bus. So it's driving the bus. And without that LS245 there, I'm not going to see any kind of signals on those lines. Okay, so I've gone into my parts and I found another 257, and this one is from 1982 as well. It's a Motorola part, so it's old. The original one I took out was a Hitachi, putting some Deoxit into the socket. Well, let's put this in. Let's just see if there's any kind of difference on those pins. Okay, there it is. Yep, no change whatsoever. That is 2, and here's 0, down at 0. Okay, so it's not coming from that chip, that particular problem. But on the other hand, without this chip in here, we don't see that clock signal on the bus either. I'm just going to take it out again and we'll just double check. And nope, we just have low. So something is instructing that chip to send the clock signal onto the bus. Now, I might be going down a dead end, a wrong direction here, because maybe this is completely normal, this behavior. I'm putting the original chip back in. But looking on B6, when I turn it on, yep, there's that crazy clock signal. And let's check on the input side. So DL2, that should be coming from the RAM, pin 3, looks absolutely normal, none of that craziness. And then when we look at pin 10, this is coming from the RAM, that's normal, that's that typical pattern. But that's going to data bit 0, which is pin 9, which is there. And notice it's just sort of down near ground, so that's not latching it onto the bus. And then here's pin 11, which goes to the keyboard, data bit 1, but it's connected to data bit 0 on the processor. And that's also just sort of floating, which is expected because nothing's connected. And pin 2 is floating, that goes to the keyboard, which is expected as well. And then the output is 4, and that's where we're seeing this clock. Now, why is it doing this? Why exactly is it doing this? Okay, so the next thing that I'm going to try doing is pulling out these ROM chips. I'm going to look for any changes in that clock signal data bus thing. No change there. Maybe one of these chips is bad and it's sending that crap onto the bus. Again, like this might be completely normal. No change. Aha, look at that. ROM F8. Now it looks normal. Let's check pin 0. Well, that doesn't look good. Okay, so 1, 2, 3, 4. All right, so with that ROM out, we now have what looks like a normal signal on data bit 2. There it is. That's coming from the RAM and the latch. But for whatever reason, 0 is still at ground, which does seem unusual. I'm going to reinstall all the chips except for the ROM F8, which sucks because I actually don't have any more of these ROM chips. They're bespoke. They're not just standard EPROMs. You can do a mod to the motherboard, and then you can use a normal EPROM, a 2716. But without that, you can't just insert one in here. Okay, so I'm just going to double check again. Okay, so this is the input to the latch, and we're getting the good signal. And pin 9, which is the output, this is the one that's held down to ground. Now, why is it held to ground? Is it actually held to ground? Because something else is holding it there. I know it's not the CPU because that's removed. Oh, you know what? It could be RAM. Let me pull the RAM chips out. Duh. All right, so I removed the 2 RAM chips that are connected to data line 0. The third one is not on the motherboard because that goes off to the language card. The RAM is connected to both the data bus directly to the CPU, but also to the side where the latches are. There are 2 data output pins on these, and so it's hooked into both. So if one of these was bad, it could be bringing data bit 0 down to ground. But I don't think so, because if I look at the latch, the input, now that these chips are missing, it's up at 5 volts, which is what you see on the scope there. But I look at the output of the latch, and I'm still stuck down at ground. And I'm on pin 2 on data bit 0. This is the data input on the RAM chip. We're going to see that ground. We're going to see that on both of these. Yep. And then pin 14 is data output, which is this pin right here. And yep, there it is. We're seeing that signal. And same on both of them. In fact, all of these chips should kind of look the same. And they do. But for whatever reason, everything is stuck at ground. And I still think there's some kind of a fault. Okay, I might have found an issue. Okay, so this is the microprocessor slot here. Sorry, I don't have a good camera angle. Next to it is the 8304. This is the bus transceiver. And I pulled that out, and I'm on pin 1, which is what goes to data line 0 on the computer. And when I turn it on, there's the signal. So that's 0, 1, 2, 3, 4, 5, 6, and 7. All of them look good now. In fact, I'm going to insert ROM F8 back into the motherboard, and we're going to look at pin 3 on the chip that's removed, and there's that clock signal back. So I'm going to say I have 2 faults here. I have F8, this ROM F8 that's bad, and I have this transceiver that's bad. All right, this is a problem because this 8304, which looks like the same size as an LS245, has a different pinout. I need to look carefully to see if I have one of these 8304s in stock. So I looked at my parts bin and I found another of the F8 ROMs. This is the first one that I thought was bad. And I popped it in and I checked the signals. And it was weird because data line 2 and 0 both had a ton of activity. And I thought, well, that's weird. 0 has activity. Now, keep in mind, I have the 8304 out. Or sorry, that's not it. This is it. 8304 removed, CPU is removed. And I was like, I'm seeing that crazy activity with all the clock signals. So I thought, well, wait a second. If the new chip is doing that, let me put the old chip back in and take a look. And I put the old chip back in, which is what's in here now. And sure enough, there's data bit 0. And there is data bit 1. And I'm like, oh, okay, wait a second. Maybe this is normal. Let me check the chip select lines for the ROMs and see what they look like. So there's an IC right next to the ROM, it's F12, and that's the one that controls the chip select lines. It's a 74LS138. Pin 7 output is the chip select line that goes to that first ROM. And would you look at that? It is selecting the line at a normal clock signal rate, and then is quickly going through all the other chip select lines. They are just high. So only that first ROM is being selected. So I thought about why it's selecting it like it is at that 1 megahertz rate. And I realized it's probably doing it because half the time the ROMs are doing things, or the CPU and whatnot, or the other half of the time the RAM is being used by the video generation to display the graphics on screen. And you can't have a ROM just selected all the time, because if you did, it would interfere with that ability of the video generation circuitry to read the RAM out to the screen. So the ROMs need to be selected and then deselected when the RAM needs to be used by something else, which is like the video generation circuitry, which would imply that 1 megahertz clock is absolutely normal. And the ROMs will probably have floating address lines. Let's just quickly take a look here. Actually, they're not even floating. They're up around 5 volts, over 4. So the ROM is going to be addressing some part of its memory and outputting that to the data bus. And that is probably exactly why we're seeing this 1 megahertz signal now on data line 0 and data line 1. There it is. And this is interleaved with the access to the memory, which we're seeing in there as well, this low part here. But on like data line 1, we're actually just seeing the RAM. And we go to data line 0, and now we're seeing whatever's in the contents of this ROM mixed with the RAM. Okay, so long story short, I've concluded that the ROM is probably working fine. I mean, it still could be bad, but that's not the issue at hand right now. I think the ROM is fine. I think the issue at hand goes back to, again, this bus transceiver and how it's holding data bit 0 down to ground, which is clearly not right. All right, I looked through my parts and I do not have an 8304 transceiver chip. And you may also notice that these 2 sockets, they look different. And yeah, there's a reason. Because off camera, I was doing a little troubleshooting, and with the CPU and 8304 in there, I noticed that I wasn't seeing the same signals I was seeing before on them. All the 8 data bits on the CPU connect to one side of this chip, and the other side goes off to the computer, and I was no longer seeing continuity on all the pins. And I realized, and I bet you people were screaming at their screen when I was doing this, but when I stuck the multimeter probe into the socket, those old sockets on there, it actually damages them. The only thing they can accept is the thin legs of an IC. If you try to put something that's round, like the multimeter probe, in there, it would push in, and I was reading the signal when it was in there, but when I put the flat IC pin back in there, you know, pushing the chip into the socket, it no longer was making contact. So yes, these are the remnants, and I think there were some more that I threw away already, of those two sockets. I had stuck the probe into both of these, damaging them, so I figured I might as well change them, because obviously if there was intermittent contact, then that could spell even more headaches from a troubleshooting perspective. So I have these sockets already on hand, so I just desoldered the old ones, put the new ones on. There were no issues, luckily, no rip traces, none of that. I just did my usual where I cut the socket up for easier removal. But that brings me back to the problem that I don't have a replacement 8304, and I am positive that that data line 0 on this is bad, and it's grounding it when it shouldn't, because taking it out of that socket, we see a very big difference. So what can we do to make something that can work in this socket, but without having this actual chip? Well, it turns out that there's actually a solution. So over here on the right, and excuse my crappy writing, is the 8304. And on the left is the much more common, and I'm surprised they didn't use this, but maybe at the time they didn't have it, the 74LS245. Looking at the data sheet, these both basically do the same thing. They're an octal bus transceiver with the ability to switch directions, so it can send the signal from A to B or B to A, or it can disable itself entirely, which disconnects both sides from the bus and goes tri-state. They both do that, but the pinout is just slightly different. If you notice on the left, we have A1 through A8, and on the right, these are the same set of pins, and they're just shifted up one. The direction pin on the 245 actually ends up being down here on the other chip, and then these chips, these pins, which are the B ports, are also down by one. And the only other minor thing is the output enable pin, which is here, is down here on this chip. Now I checked the schematics for the Apple II, and the reality is that these two pins here are actually connected together, and they are ground. And that's because this chip never gets disabled, it's always enabled, and it just switches direction. So that means for the 245, we just need to get ground up to this pin, so it's enabled all the time, take a 245, and we can actually stick it into the socket, shifted one set of pins. So that means that pin 2 becomes pin 1 over here, and the output enable pin right here goes into the VCC pin on the motherboard, but we don't want that. So I'm going to have to build a little adapter to pass through most of the pins, because this pin 18 here would end up going into the pin 19 if I shifted up one. And that means that 0 through 7 and 1 through 8. I mean, just ignore that the numbers are 1 and 8 and 0 through 7. It's the same thing. They'll be all lined up. And then the ground pin, pin 10, will actually go into this pin, which is chip disable, which is tied to ground all the time. So that's going to create the ground. So all that really needs for pins that need to be rewired is this direction pin, the VCC pin, and the output enable pin. Everything else, if I just shift the chip up one set of pins, then it'll all be in the right spot. I don't think I did a great job explaining that, but hopefully you kind of get the gist of it. But what I did is I took two chip sockets and I inserted them into each other offset by one pin. So you notice that is there. And then I rewired those 3 extra pins that I talked about from the diagram there. So the 2 pins that hang off the edge here, one of them is VCC. So I'm just pulling it off the VCC pin on the board. And then the output enable pin, which would normally plug into the VCC, which it can't, I've cut that pin right there. And on the other side, it's hard to see because I've already put this together, but there's a wire that goes from there and it goes right into here, into the ground pin that would go into the motherboard. And then this other pin, that's the direction pin on the motherboard, comes up and it goes right to this pin that's hanging off, which is the direction pin on the LS245. And you see I actually have an LS245 inserted there into the socket. And theoretically, this should work. Oh, and the other thing I didn't mention is I don't push the sockets all the way into each other, and then I solder all the other pins that go together. I've had other videos where I make these types of adapters, and there's some good instructions online for doing these types of things. It's all basically the same thing. But anyways, I did some Googling looking for people talking about this particular swap, like if they couldn't find the 8045, and I didn't really find anyone talking about it. But I looked through the data sheets to make sure that the direction pin that controls if it goes from A to B or B to A is the same on the both chips, and it is. Both chips take the direction signal and work with them in exactly the same way, and the A and the B sides are on the same sides, so theoretically, this should totally work. So there it is in the motherboard. It's a little bit of a triple stack. Obviously, I could have eliminated one socket by soldering these wires and bending pins directly on the IC, but that would have made it a permanent thing in there. And at least with this, if I ever get one of these original 8304s, I can actually put this back in the motherboard, eliminate this adapter, so there's no permanent changes. And then if the 245 ever dies, well, then I can also swap that out because it's not soldered into the socket. But it ends up with this little bit of a tower here, and theoretically, something plugged into slot 5 here might interfere with that. It's possible, just depends on whatever's on that board. And here is the original CPU. Let's put this back in here. There we go. Incidentally, I still have the original ROM chip back in here. This is the one for my spare parts. I'm going to keep this off to the side in case this is bad, but I actually really don't believe this is bad. I think I was going down the wrong path with that data bit 2, which had that clock signal looking bad. That actually sounded normal on this. It was all about that data bit 0 being stuck at ground when it shouldn't have been. And then when I pulled out the 8304, it went to normal. So I really feel that this was the only fault. I also have all the original RAM back in, and I have the original LS257 back in here, the Hitachi part. This was the Motorola one that I was testing with originally. Okay, I've done enough talking. Let's see if this adapter stack and an LS245 in place of an 8304 actually works. Here we go. Oh, look at that! Would you look at the sweet, sweet Apple II logo? Oh, that worked. How cool. Okay, I'm excited. Uh-oh, what happened? Picture just went away. Okay, I think I have a problem on here where, yep, when I turn this, it sort of twists, and I think this has lost its ground connection, which causes instability on the screen. In fact, look at this interference on the screen, but if I sort of jiggle this, oh, it comes and goes. Yeah, okay, so I think that's unreliable. Let me try to fix that. So it's a pretty common problem where basically the RCA jack disconnects from this grounded part. What I'm going to do is I'm going to heat up the soldering iron, and I'm going to just add some solder right onto this lip here. All right, so that's not super pretty, but I think it should do the trick. I can tell when I plug this in, if I twist it, it doesn't turn anymore. Yeah, and that is the case. Let's give it a quick test. Yep, it's now rock solid, no issues whatsoever. Looks good. Okay, so this socket goes bye-bye into the garbage. Okay, so the computer at least goes to basic, but as we know with the Franklin Ace, that doesn't mean it's actually working fully. So I'll need to do some more testing. But first off, I need to see if this keyboard works, especially after cleaning it. It certainly looks a lot better, but does it work? So the keyboard connects right here to the motherboard, and it has this pin header type cable. I did put a piece of foam over here. It's very easy to bend those pins, so I protected it. A couple of them are a little bent. I'll straighten those. All right, so from an orientation perspective, pin 1 has a little dot there, and then the cable with a stripe on it goes towards pin 1. So it goes in that way, just like so. Not a lot of space on my bench. I'm going to try to get this all situated. Okay, I think that's good. No, this is just sitting on the rubber and on the desk, not on the motherboard. Okay, here we go. Turn this on. Okay, the power light's on the keyboard, so that's a good sign. That's H. Okay, I'm going to try typing hello. Oh, spacebar is not working very well. It's sort of working. Okay, A. Okay, yeah, some of the keys are definitely, they're actually coming back to life. Adrian Black. Yeah, okay. So this thing, all that filth and dirt has gotten into those switches, and I'm just going to try to type all the letters and figure out which ones don't work. Oh, and at least reset works, and pushing on its own does nothing. pushing control actually does the reset. So you definitely need the control there. So control works. Okay, that's good. Let's see. Oh man, I gotta start writing down which keys aren't working. This sucks. Okay, here's my list. So this top row, all these keys are either don't work at all or they're very flaky. And then X, when I push that, I get tons and tons of X's. So it's probably has bad contact inside as well. I think the first thing I'm going to do, I'll just pull these letters off, and then I will spray Deoxit or drip Deoxit down into the key switch and see if that works. All right, that's going to be it for this video. So in the next part, I'll be fixing this keyboard, hopefully for good. And then don't worry, there are other faults with the machine that are going to come up, and then I will fix. So watch for that video coming soon. If you enjoyed this video, I would appreciate a thumbs up, but if you didn't, you know what to do. Hit that subscribe button to subscribe to my channel. Of course, the bell icon to be notified. Maybe. Some people say it works, so hit that button. And then, of course, put your comments and your suggestions in the comment section below. And that's going to be it. Thank you very much for watching. Stay healthy, stay safe, and I'll see you next time. Goodbye.